Okay, so we will continue with section 2.6, composition of functions. And so first, let's start with the definition of the domain. The domain of FF is the largest set of real numbers for which fx is real. So this is very important. We all learned square root negative 1 is I. Yeah, so but it's not real. We wanted fx to be what? A real numbers. Okay, and so there are four types of functions that we need to pay attention to the domain. So and the last of the type 4, which we will learn in chapter 4, so we will not learn it now. So the type 1 is what? Fraction. Is rational functions. It's a fraction. So what will be the domain of the fractions? And your denominator cannot be equal to what? 0, because any number over 0 is undefined. Yeah, so the domain for the fractions, for the rational functions, is denominator cannot be equal to 0. Okay, so I use x. So fx equal to square root of x. The radical functions. What will be the domain for the radical functions? The radicand has to be bigger than or equal to what? 0. Because do you remember what is square root of negative 1? That's I. Yeah, so it's not real anymore. So it's not in the domain. Type 3 is the combination of the type 1 and 2. It's 1 over square root of x. So you have rational also combined with the radical functions. What do we have here? Radicand has to be bigger than or equal to 0. And because on the denominator, so it cannot be equal to 0. So its x is strictly bigger than 0. Okay, and the type 4 is called what? Logarithm function. And the domain for the logarithm function is what? X bigger than 0, 2. And here b can be bigger than 0, but cannot be equal to 1. Okay, so let's practice some questions. Okay, so let's look at here. So what will be the domain? We have fractions. We only need to pay attention to the domain. So x minus 3 cannot be equal to 0. X cannot be equal to 3. And then also x squared minus 4 also cannot be equal to 0. How could we solve this? So x squared cannot be equal to 4. Then x cannot be equal to plus or minus 2. Do not forget plus or minus. Yeah, so let's see how could we graph it. Negative 2, 2, 3. Yeah, so cannot be equal to. What happens here? We use what? Open circle, open circle, open circle. Okay, so we cannot be equal to here. Okay, and how could we use interval notations here? And every open circle will turn into what? 2 parentheses, because not include these points. Yeah, so not include open parentheses, parentheses, parentheses. So what will be the interval notation now? It will be the first leftmost interval. It will be negative infinity to negative 2 union negative 2 to 2 union 2 to 3 union 3 to infinity. Yeah, so it looks nice. Yeah, okay. And the set builder notation, which will be x cannot be equal to negative 2, 2, and 3. The set builder notation for this one is easier, but typically they will ask you the interval notation. Okay, so for the next one, so the radicals function is on the numerator. Okay, so it's not on the denominator, so then the radicand has to be bigger than or equal to 0. This means x minus 1 bigger than or equal to 0, then x bigger than 1. But at the same time, you also need to what? Make sure the denominator cannot be equal to what? 0. So x cannot be equal to what? 5. So you have to satisfy both of these two things at the same time. So you have 1 at 5. Bigger than or equal to 1, so you go right here. And then you have an open circle here. No? At 5. Open circle, it will be what? Turn into parentheses here. So what will be the interval notation? It's from 1 to 5. 1 to 5 union 5 to infinity. This is a tricky question. Be careful. Okay, so the next one we wanted to introduce composition function. So what is a composition function? Composition of function f with j is denoted by f small circle in between j, and is defined by the function f composite j of x is equal to f of j of x. Okay, so the domain of f composition of fj satisfy x has to be in the domain of j because closer, and then g of x has to be in the domain of f. Okay, and some other properties of the operations of the functions is you can add two functions, you can subtract, and you have multiplication, and you can divide. But when you divide, you need to be careful the denominator cannot be equal to 0. Really good. Okay, so what will be f plus g of x for this question? According to the formula, it means what? Fx plus what? Gx. So what will it be? 3x squared plus 8x plus what? 15 plus gx is x minus 5. Then what will you do? Combine like terms. As we learned before, 3x squared plus 9x plus 10. So f of gx, when you do the division, that will be fx divided by gx. So what do we have here? 3x squared plus 8x minus 15, just keep it here, over x minus 5. Okay, but what will be the domain here then? Domain, numerator, we do not care. For the denominator is x minus 5 cannot be equal to what? 0, so x cannot be equal to what? 5. So the domain is x cannot be equal to 5. And similarly, what will be the interval notation? On 5, open circle become what? 2 parentheses. So negative infinity to 5, union 5 to what? Infinity here. Okay, so this is this one. The next one we wanted to practice, find the composition of f circle of gx. So listen to here carefully. Okay, f composite with x is equal to, according to definition, what does this equal to? It means f of g of x. Okay, so f of gx. This is from what? Definition. Okay, then what will be the next step? What is g of x? It's here. So you substitute gx. So it's square root of 8 minus x, yeah? And then what will you do? You evaluate f of x. Okay, so this means this is your new x here. You with me? Yeah, so this is your new x here. This becomes your x. So what will be the fx? All the x will be replaced here. So x is square root 8 minus x. So it is 1 minus square root of what? 8 minus x. Are you okay? Yeah. So what will be the domain then? So the domain here is 8 minus x bigger than or equal to what? 0. Okay. So, I wanted you to keep the x on the left side, like x negative less than negative 8. Then you divide by negative 1. What happened? X is less than or equal to 8. You with me? So what will be the interval notation? Negative infinity to 8. Okay. So this is this one. So the next example is fx equal to 7 over minus x minus 6, gx equal to 7 over x plus 6. So we want to find, f circle gx, g circle fx. Okay, so let's see what is going on. So the first step is also what? F or gx, and you substitute the 7 over x plus 6 for gx. Then what do you do? Look at the whole thing as the x and put it here, yeah? So it will be 7 over your x become what? 7 over x plus 6. That's your x. Then you minus 6 again. So what do you have? 7. This cancel. So 7 over x. What do you have? 7 times x over 7, yeah? So and 7 cancelled. So you have x. Clear? Okay, so be a little bit careful with this one. Yeah. Similarly, g of x is g of fx. Then you substitute the fx here. And what will be this? Do not forget, you have to replace the whole thing inside here for the x there. So what do you have? 7 over x minus 6 plus 6. So what will you do? When you divide fractions, what will you do? Is multiply the reciprocal, yeah? So 7 times x minus 6 over 7. 7 is 7 over 1, yeah? So the 7 will be cancelled. So what you have is x minus 6 plus 6 equal to x. Okay, so these are the ways that the rules that you use to calculate the composition of the functions. Okay.